Here's exactly how to read construction drawings so you can find the information you want to know without drowning in confusing section views. I'm going to go over the basic types of construction drawings, how to understand them, what they show, and how to go through them in an order that makes sense. I don't care how good you are at reading drawings, but if you open a set of plans and this is the first thing you're looking at, it's confusing. It's like opening a book and starting to read from the middle. So my first and most important principle of reading drawings is simply to read them in the correct order. You first need to establish a spatial overview and understanding of what you're actually building. And the way to do that is to start with some sort of system overview or isometric view. Anyone looking at this can instantly tell that we're building a warehouse, and you need zero technical experience to be able to do that. So typically on construction drawings, the first page, or it should be the first page of any set of plans, is an overview of the project. And you want to start there and you want to get a conceptual understanding of the scope being delivered. For example, this is an aerial 3D view layout that shows a berm being constructed. And you can see the layout plans clearly show the length and orientation of the berm, and there's some sort of excavation here. Not all construction drawings are nice enough to start with some simple isometric overview. Other sets of drawings, you might have to scroll through and find some sort of layout or plan view. And you should always read these drawings in parallel with some sort of scope of works to basically, again, form this conceptual understanding of what you're building and how the scope is broken down. Now, that's great for civil and structural drawings, but if you're dealing with mech, elec, and plumbing drawings, you're not necessarily looking to see visually how it all fits together or spatially how it all fits together. You're more trying to understand what are the different systems and how do they connect to each other. For example, a plumbing set of drawings will show a wastewater layout, a fire and hydraulics, potable water layout, and maybe some sort of rainwater layout. For plumbing drawings, the plan views is a relatively good place to start because you're looking at how the system fits together. So you can see where the inlet is, where the outlet is. Things like mech drawings, you're looking at where the fans are and where the ductwork is running. But for electrical drawings, the plan views aren't the best place to develop your understanding of the system. For electrical drawings, you actually want to find the single line diagram, which shows the power flow throughout the building or facility. So for example, this drawing is showing the transformer, the incoming street supply, how it's stepped down to 415 volts, and then how it's distributed throughout the facility through distribution boards and a main switchboard. Later, we can then revert to the plan views to see how all the circuits, light fittings, and power outlets are connected to these boards. For comms, you want to find the communications system overview, which shows the overall network architecture. Okay, awesome. We should have our understanding of how everything fits together if it's a civil, structural, or architectural project, or if we're doing some sort of mech, elec, or plumbing system, we should have an understanding of the key components of the system and how everything interconnects. One additional thing I'll say is you also want to look at the title block of the drawing to understand the revision and status of the drawings you're looking at. This is important for the primary reason that if it's something like issue for tender or preliminary issue, there's still detail to come. When if it's issue for construction, there is no additional detail coming. What you've got is what you've got. Okay, so when we were developing the understanding of the system, I mentioned the plan views. The plan views are an aerial snapshot of a set of construction drawings. You can imagine a bird above the project looking down. You've got a bird's eye view of the project at a specific height. So if you can imagine this one, this is a cut through the building at a set height of 31.25. The heights you see on drawings, things like this 31.25 or the top of footing at 30.95, these are referred to as the RL or reduced level. Now, the absolute value of that number, so 31.25 as opposed to 1.25 or 60.25, doesn't necessarily matter because it's the relative height between these points. These heights are all fixed reference to some datum point. That datum point is what the surveyors will use when it comes out to actually setting out these drawings on site and marking these heights for construction. But in terms of how we read and interpret the plans, we're more interested in the relative differences between the heights. So again, we can see on this set of plans, FFL, which stands for finished floor level, is 31.25. So the finished floor level of this warehouse will be at the RL 31.25. The top of the footings, so all these individual footings that support the structure of the building, they are at RL 30.95. So we can say the difference in height between the top of the footings and the finished floor level is 300 mil. So the actual slab, the screed on top of these footings is going to be 300 mil thick. Now, the other important thing to understand when you're looking at plan views are grid lines. So grid lines are reference points that are consistent throughout the drawings. They can be both horizontal like these ones or vertical like these ones. The reason it's really important to look at the grid lines is because when we start to talk about elevation views or looking at the structure from side on or section views, they're going to reference these grid lines. So for example, if I note down W1, W2, W3, a grid line like this, if I then go to look at an elevation view, I'll see that there's a reference to this grid line. So I've gone to the back of the drawings and I've found the elevation views. This is the north elevation view, which is looking at the structure from the north side. And I'll go back to the plan view to show what this means, but we can see a reference to these grid lines, WA, B, C, D. Now, they've done it a bit weirdly on this set of plans, but that is the compass. The darkened angle is the north. So if you can imagine, I'm looking at this structure from the north-hand side, I can see grid line WA, WB, WC, WD. So that is my elevation view. I'll go back to it in a sec. I'm looking at it from the north-hand side, and these are the grid lines I can see. So if I go back to this elevation view, I'm standing on the north face of the structure, looking in. On the right-hand side is WA, and on the left-hand side is WD, which matches the order of the grid lines on the drawing. So again, the person looking from the north, on their right-hand side is the WA grid line, and on the left-hand side is the WD grid line. So the elevation view, again, is just looking at the structure from ground level face on. So you can see the height of the warehouse, things like doors, different changes in materials. For example, the base has concrete, the higher levels have a structural steel frame. We can look at the north elevation, the east elevation, south or west elevation. So these are all the external angles looking into the building. Typically, we'll also have some internal elevations. So these are a series of internal elevations looking at the warehouse. It's referred to as portal frame PF1, PF2, PF3. So they're not referencing the actual grid lines, they're referencing these different types of frames. So you can see in this structural drawing, which is a plan view looking at the roof of the building, is in here, they have named the different types of portal frame. That is PF1 type frame, there's a PF1, that's PF1, that's a PF2. So that PF1 frame, that is an elevation view of this structure. So if I look at a different set of drawings, so this is an electrical set of drawings, you can see I've got these same grid lines which help me orientate to where I am in the structure. We've got both the horizontal and the vertical grid lines, and then I can see an orientation of where the equipment is. So this, instead of being a floor level plan, this is a reflected ceiling plan, so I can see where stuff is installed in the ceiling. Again, it's just a geographic layout showing where everything is. On any sort of architectural building or layout, typically you will have one standard architectural layout which references and names all the different rooms in the structure, and this same set of layouts will be used for the mech, electrical, plumbing, all the different, or like the furniture fit out, all the different types of drawings will reference this standard layout. So basically, we've got a broad overview of understanding the overall structure, the system. We've understood the layout drawings, both looking vertical and then the elevation views from looking across. That is when, once we understand this, we understand clearly how everything fits together. Only then do we start looking at the section views. I can guarantee if you start trying to go through and understand the section views before you've developed this understanding of how all the drawings fit together, you're just going to unnecessarily confuse yourself. So section views, they're basically blow-ups of certain types of connections, so you can add more detail to the actual construction and show exactly how it's going to be built. So for example, this is the interface between a precast wall and an in-situ slab. You can see exactly the reinforcement details. So this has 2 layers of SL102 steel reinforcement mesh, shows the connection from the base slab or the actual support foundations into the precast wall. It shows the 300 mil thick slab on top of that, and it shows all sorts of interconnection details. This actually references another section view. So section views typically are labeled by cuts, and they'll have some sort of reference that says BB, or if they reference another drawing, typically it will have a letter which will be the section view number, and then it'll give dash that other drawing. So you might have to flick to another drawing. But this section view, the arrows indicate what direction you're looking, and what angle. So this BB cut, we go to view BB, and you can imagine we're looking at that connection joint front on. So this detail is showing how that footing ties into this slab. So you're looking at it from this angle, and on this detail, you can see a connection from this slab. So you can see a connection from this footing into this slab, which is looking like this to this. So section views, again, to really understand the angle you're looking at. And the purpose of these section views is really just to show additional detail that's impossible to show in any sort of plan or elevation. If I show you a different example, not from a concrete project, but from a wall penetration, you can see this is a detailed section view of how a mechanical duct penetrates through an architectural wall. Now, you can see the vents, you can see the duct, but again, to understand this, you'd probably have to have quite a good understanding of the actual mechanics of HVAC and architectural and building work and understand what all these terms mean. Obviously, it's hard to read the drawing if you don't understand what all this stuff is. I'm personally not very good with architectural and mechanical stuff, so this doesn't mean a lot to me. But concrete, something I'm much more familiar with. I can look at a detailed section view like this, or like this, and I have a pretty good understanding of what is actually involved in the construction. So yes, what I'm saying in a roundabout way is conceptually understanding what's being built, how stuff fits together. You probably don't need much of a technical understanding. By the time you start to try and make sense of a blown up detailed section view like this, it's not necessarily your skill of reading drawings, it's your skill of understanding the actual construction material and methods. Now, the final step in this process is the understanding both the drawing index, which is, again, it's just a quick, almost like a table of contents for a set of drawings, and the general notes. The general notes just provide supporting supplementary details and specifications, but really, a lot of the time, they're just the architect's ways of covering themselves if they've made any mistakes. So they'll put a whole lot of additional detail in here, basically saying the contractor's responsible for anything the architect's missed is automatically the contractor's fault. So look, yes, these are very important, but you have to read them in context with the drawings, and they just provide supplementary information. So for example, this is talking about concrete notes. It's giving specifications on the type of concrete and the material of concrete. Obviously, if every time there was concrete referenced on the drawings, it would be impossible to give all this additional information. So this is just information that supplements how you read the drawings. Now, if architects are nice, the other thing you'll get in drawings, which makes your life much easier, are schedules. So schedules will have things like quantities and specific material specifications. And again, they help to succinctly explain details. So for example, this is a footing schedule. It references all the different types of footings. And I don't know what I had on then. Should have had the pen. It references all the different types of footings. So you can see this F1 is a 2500 by 2000 by 900 deep. And then on the set of plans, we'll see references to F1, although I don't see any. But let's just, here it is, F1. So that footing is a 2500 by 900 by deep footing. Again, it makes it easier to read and understand rather than someone writing on the footing 2500 900 by 900. So again, schedules help you get quantities and apply detail to the drawings. Or for example, on a series of mech drawings, here the architect's given us an actual mechanical equipment schedule where it's listed out every single air conditioner, air handling unit, fan, and so on and so forth. And it's given supporting information, the quantities, and all the details that we need. I mean, a lot of this stuff is common sense, but really, I guess the key point I'm trying to make as well is don't expect to be able to instantly interpret what all this stuff means if you don't actually understand the technical side of it. So the materials, the methods, what actually is concrete works versus civil works. The better you understand that stuff, the easier it is you're going to be able to understand the drawings.